continuation of the list of formula that we have done. Point number 24, if L of f of t equal to f of t, then the Laplace transformation of integral 0 to t capital F of u du is given by 1 by t f of t. Similarly, if L of f of t equal to small f of t, then Laplace transformation of multiplication t times of capital F of t equal to minus d by dp of derivative of f of t. If L of capital F of t equal to f of t, then Laplace transformation of t power n into f of t is nothing but minus 1 whole power n into nth derivative of the function of f of t. And if Laplace transformation of capital F of t equal to small f of t, then Laplace transformation of 1 by t capital F of t equal to integral p to infinity small f of p dp, provided the integral exists. And then we have also learned about the inverse Laplace transformation. Corresponding to that, we know that L inverse of 1 by p equal to 1, L inverse of 1 by p minus a equal to e power a t, L inverse of 1 by p power n equal to t power n minus 1 divided by n minus 1 factorial, where n equal to 1, 2, 3, etc. And we are having L inverse of 1 by t minus a whole power n equal to e power a t into t power n minus 1 divided by n minus 1 factorial. And L inverse of 1 by p square plus a square equal to 1 by a times sin a t. L inverse of p by p square plus a square equal to cos a t. L inverse of 1 by p square minus a square equal to 1 by a times sin h of a t. L inverse of p by p square minus a square equal to cos h a t. Similarly, L inverse of 1 by p minus a whole square plus b square equal to 1 by b times e power a t into sin b t. L inverse of p minus a by p minus a whole square plus b square equal to e power a t into cos b t. L inverse of p by p square plus a square whole square equal to, we can prove that is equal to 1 by 2a times t into sin a t. These are the two formula, and in addition we have to remember, we have done the problems. L inverse of 1 by p square plus a square whole square equal to 1 by 2a cube into sin a t minus a t times cos a t. And when it comes to partial fraction, a kind of revision. If the denominator is going to have these kinds of points, that is non-repeated linear factor, simply p minus a, then the fraction will be taken as a by p minus a. If we are going to have p minus a whole power r, that means a is repeated, p minus a is repeated r number of times, then the fraction will be taken it as a1 by p minus a plus a2 by p minus a whole square plus so on, ar by p minus a whole power r. When it comes to non-repeated quadratic fractions, what is quadratic factor? P square plus ap plus b. Then under those circumstances we consider the fraction as ap plus capital B divided by p square plus a square plus b. And similarly, if the fraction is repeated r number of times, that is p square plus ap plus b whole power r number of times if it is repeated, then the fraction will be taken it as a1p plus b1 divided by p square plus ap plus b plus a2 plus a2p plus b2 divided by p square plus ab plus b whole square plus so on, arp plus br whole divided by p square plus ap plus b whole power r. And the final, the last topic, that is convolution theorem. If small f of p and small g of p are both Laplace transforms of capital F of t and g of t respectively, then the product f of p convolution g of p is nothing but Laplace transformation integral 0 to t capital F of u into g of p minus u du. Okay, thank you for watching this.